Okay, microphone check. It's looking good. Hi there, Jason here from Instruo. This is a bit of a new format for me. It's taken a minute to try and get everything set up so I can screen capture with audio and microphone and all that. I'm much more used to messes of actual cables, so this is fun. Like a bit of tech spec to start with, just so everyone knows what I'm running this on, if there's any tricks or quirks. It's pretty much just straight up vanilla rack. I've got the Instruo library installed from the main rack library. There's a few other things I've got in just as needed. So platform wise, this is just the standard installation. I'm currently running on one of the new Apple Silicon MacBook Pros, which I've been very impressed with for performance. So this is rack running through Rosetta 2. I don't have the natively compiled for ARM, which I think there are some betas out there for that approach. But yeah, this is just the stock installation, and you can see I'm able to run this at 192 internal. I'm using the built-in headphone output, which is then going into a separate sound card, then that's capturing into QuickTime. Yeah, I'm still able to run that out at 96k. I think I might even be able to drop this down to 128 buffer size. Yeah, we'll see how that runs as I go on digging some patches. Let's put that back just now. Cool. So I don't have the strongest of plans for what to cover in this video. I've got a few ideas based on just seeing how people have been using the modules since we launched them, which has been a lot of fun, because there seem to be some common tropes in software patching compared to how it might be done on a physical system. So I think that might be more of my focus, is just seeing, based on some of my observations of how people are using the modules and some common techniques, and just how I might approach doing similar patches in analog, and if there's any tricks in between the two platforms. So I think it could be good fun. Yeah, you can see I've been experimenting with some extensive wave shaping and cross modulation here, so that's going to be the basis of the patches I'm going to dig through. Yeah, so hope you enjoy. I'll start a new patch and get going. Okay, so let's dive in. There's a particular foundation patching technique that sort of inspired me for this video. I see it quite regularly in a lot of different patch tutorials, and just in general, in a lot of the content that's out there that's built around VCV rack or other virtual modular systems. It's an approach for creating more complex waveforms from more basic oscillators that have just the more fundamental waveform outputs individually, and that's using mixers, much like this, where clock this from the oscillator as well. There we go. If I bring all the levels down, we have just a combination of foundation waveforms to create more interesting timbres. And it's a very powerful technique. Here we go. Let's actually listen to this as we go. So maybe starting from a sine wave and splicing in elements of square waves, maybe wavefolds. The TSL in particular, we've got the complex PWM voice and the wavefolder, so there's a lot of interest that can be built in very quickly. then of course for dynamically shifting the timbre, we can add modulation to particular voices. Maybe add some modulation to the wave folder itself. So this might be a bit better if I had if I full wave rectified the LFOs, but we get the picture. It's a very very simple conceptually way of creating interesting waveforms. The downside being, if you're not in a virtual environment where you've got infinite patch cables, infinite mults, infinite VCAs, it's a very heavy patch. This is 4 outputs going into a 4-channel VCA mixer, which they do exist, but it's going to get quite costly just to build a single foundation waveform, and then modulation over those, etc., etc. So what I'd like to demonstrate as we go on more is ways of combining internal routings and different modulations to create tonal complex waveforms that can be used as the starting point to subtractive patch, where you might run this entire thing through a filter. So fundamentally, it's a subtractive patch, but instead of using solid square wave or sawtooth wave, I've got something that's foundationally a bit more interesting. There's a bit more movement in there. But again, instead of going just oscillator into filter to VCA or output, this is a lot more patching involved just at that initial starting point. So my tool of choice for the bulk of this video is going to be the CSL, which is it's got a lot of routing, a lot of complexity ongoing under the hood. But it's going to give us a lot of things to play with without going for the classic just pulling from multiple outputs in parallel and mixing them. There's a lot of ways to generate complementary and contrasting different waveforms from the module itself. So for most of the time, I'm just going to be pulling from a single output and then wave shaping to get the richer timbres. So I'll move these up here just now, and let me just turn that down. So the main trick I'm going to be using is hard sync, which the vast majority of oscillators will do some sort of sync, be that hard sync or soft sync. I think it's a very underutilized approach and technique. It's almost too simple in a lot of ways, but you can get some extremely powerful results from it. So let's keep things simple. Let's just listen to sine wave from the top oscillator here, and we'll keep it at that. Just no mixing of multiple waveforms. There we go. So I've engaged the hard sync via the sync button here. So when it's white, the sub signal of this lower oscillator is what hard syncs the core. So if I use this as my clock signal, we'll now be able to see the fundamental frequency. So as I bring this up a bit, we can see 2 repeating cycles. and within those cycles I can force additional oscillations based on the index ratio between these two oscillators. So as I bring it up, I'm getting that classic overtone series sweep as I'm adding more cycles inside the main carrier signals cycles. So let's match them. Here I've got sine wave now, which is the two oscillators tuned 1-to-1, and as I reduce it down, I'm now at only half a sine wave cycle per period of my main fundamental. And already very quickly you can see that's going from a sine wave, the split's introduced, and it's folding up to a sawtooth wave. So all I need to do to add CV over that as a wave shaping technique is a little bit of frequency modulation over the top voice. So if I go with the slower mellophone here. There we go. Balance those two frequencies, so I'm now going from the matched sine wave to a little bit below half a cycle in between. This is now fully dynamic wave shaping from sine wave through to sawtooth wave. So without having to use a mixer and combine two final produced waveforms, it's just hard sync and FM. So two patch applications essentially. And this can sound great on its own as the basic patch method. It's almost like that resonant filter type sound, but with a more aggressive split. So to soften that itself, that might be your starting rich waveform. We're just softening that peak, or that hard edge a bit. There's maybe a bit more control than if you were just running this through a resonant filter, for example. Okay, let's get things a bit more interesting. I'll take resonance off. I'll just keep this cutoff all the way up so that we can soften the tone as we want, but it's essentially just running through the filter, unaffected. So let's create some more melodic control over our voice. So let's create some sort of sequence. I'm going to use the TSL as a clock source and clock a sample and hold. This way, if I want to clock anything else in this patch, I've just got a single source that I can draw from. So I could just patch this alone into my volt per octave. Keep things tonal. Let's quantize that. Full wave rectify this, so it's unipolar positive, and let's go with minor triad as our basis. Okay, to get something that's not sampled noise, that's not completely unpredictable, let's undersample a triangle wave, we'll get some sort of melodic pattern. I'm going to take FM off here at the moment. So what we can see as the volt per octave's changing on the fundamental pitch, which is my clocking oscillator, so we're listening to the sine wave still, but it's remaining at a fixed constant frequency. As the fundamental of the syncing oscillator changes around it, the timbre's changing per note based on the ratio between the two. So to get something a bit more consistent, I can hit the link button here. This means that volt per octave is now going to both cores simultaneously. So whatever the ratio is per note, we're going to have a consistent waveform. Which of course might be an option you want to play with depending on the patch context. It's quite nice having variation of timbre per note. Okay, let's introduce some more cross-modulation. I'll match it so it's 1-to-1 ratio, and keep this linear FM and start to bring in some FM depth. So we can see the wave shape's changing. We're getting a bit more flattening on the top and then it's splitting down the bottom. So what's happening here is on the CSL, the sine waves cross-normalized to the opposite oscillator's FM input. So this sine wave is actually routed here. As I bring this attenuator up, we're adding frequency modulation from the bottom oscillator to the top oscillator. Change over to exponential, we get much more aggressive wave shaping. But again, this whole voice is remaining tonal. It's remaining a periodic waveform. So let's try this unlinked. This is almost like a form of asymmetrical wavefolding. You see, folds are introduced per cycle based on the relationship between the two, and frequency modulation added in. If I take off the hard sync, you hear that classic clangorous analog FM tone. So as soon as the hard sync's engaged, it just locks things in. So this could be an interesting experiment. If I add in an envelope and just clock that from the result of the harmony, keep it just a percussive decay envelope, go exponential. If we listen to this on the filter, it's a nice character. There we go. Let's just open the filter up entirely and let's use that envelope to affect our index ratio between the two oscillators. A little bit much, let's attenuate that down. Maybe getting into slightly more atonal territories than we'd want. Okay, so let's try a new output as our source. I'm going to switch both these from the sine wave down to the final output. If I bring the fader up to the center, it should be much the same as what we had before, slightly lower amplitude. So now this resulting sine wave signal, which is frequency modulated and hard synced to the bottom oscillator, can be folded in on itself. Which adds a lot more complexity to the waveform itself. This is quite a nice parameter to modulate with an LFO. A lot of sort of vocal characteristics starting to come through. Get that to a spot where it's sitting nicely. Yeah. So I mentioned earlier that the hard sync relationship from the top oscillator being hard synced to the bottom oscillator's frequency. This is coming from the sub output. So as I change the sub, it's actually that halving of frequency, which is the sync signal. So immediately I can change octaves on the fly. This will come to play a lot more as I start doing more combination between the two voices. So instead of this being modulated externally, let's turn on some internal routing. If I right click and go from oscillator B to oscillator A, wavefold. This adds further complex wave shaping to the result. So this is folding the resulting signal. If I bring some of the combination down a bit. As I increase this, it's the sine wave through the index control to the attenuverter input. So what we'll have now, if I reduce this down a bit, we're kind of getting a sum of the sine wave via the modulation depth, so that's essentially amplitude modulation over the wavefolded sound. If I change the sub relationship, we're going to retain some aspect of the higher fundamental. quite as wide a spread because we're retaining more of that top end and adding subharmonics. So a lot of these waveforms so far are very symmetrical in a lot of ways. It's like similar to just raw wavefolding. There's a you can see there's a lot of symmetrical folding, which a lot of times can accentuate more all the odd harmonics, so more like a square wave compared to a sawtooth wave. So how can we introduce more of that asymmetrical ramp, which will give us a wider spread of all harmonics? At the moment, this wave folder is folding oscillator B's sine wave. So what I can do, I can patch this here. Oh, not in sync, into here, into the symmetry input. Folding takes a much more slanted shape, I find. Like, you get those elements of the sawtooth ramp coming through compared to so the folding is occurring more in the these clusters, whereas with the sawtooth there's almost more bigger movement with the outlines of the ramp shifting through the 0 point. Turn this into more of a finalized subtractive voice. So this is a bit more reminiscent of where a patch might go using some sort of subtractive filtering stage after this source complex voice. So if I spread things out a bit more, so we have, this is essentially our sequencer. We've got one modulation source, which is actually not even affecting the raw voice so far. And the CSL is still very much just on its own as a standalone single oscillator that we're using a single output from, which is going to the filter. And at the single turn of a knob, we've got a huge range of timbral shift. Try an additional step. So this is using wavefolder of the top voice clocked from the lower voice. Let's look at the multiply section here. So by default, the sine waves from each voice connect to the normals of these two inputs, and then the output is the multiplication of the two, and that can be defined so that the top voice of the multiplication pair can be either ring mod, AM, or rectified. So ring mod is the LED off, and that's 4-quadrant multiplication. AM, it half-wave rectifies the signal seen here, and full-wave rectified, all negative portions will be flipped up to positive. So let's switch these over. So we still have some sharper spikes. This is all resulting from the two sine waves. So we have that hard sinking split occurred, but because it's a multiplication between the two, it's a very different timbre. So what I'm going to do, I'm going to change that sine wave to being our previous final result. It adds another range of character to the signal. Let's try out the different rectifications. This is AM, so this is half-wave rectification, so it's lopping off anything that's negative from the final output. So full-wave rectified. So a lot more of the busyness is happening in the positive domain here. Okay, let's say we want some more sharp edges added in. Instead of multiplying with a sine wave, let's go with something that's got a few more edges. So we could either use the square wave itself. It's quite nice in itself. Let's use the pulse width voice. There we go. So that's adding in many more steps and layers to the resulting waveform. This would be quite a nice parameter to modulate, actually. Let's add a vinca. Use this for CV depth scaling. Stop it pushing those upper and lower bands of the square wave out of range. What I've done now, I've unlinked it so the top oscillator is free running away from volt per octave and dropped into LFO territories. So with it now being unlinked in volt per octave, it's now a fixed constant that's being hard synced from the lower voice. Let's remove that normalization and go with external modulation now. automated movement in the folder mount. New melody to mix it up. So now if I backtrack and sort of break this down a bit more, we're using CSL as our single oscillator's voice. Our output is still just a single patch cable, so we're still not branching out multiple outputs to combine them with a mixer. We're using just a single patch cable out. That's just clocking the scope for consistency. We have our single volt per octave signal coming from our sequence, and then I have 2 external modulation sources. So cutting it down from, if we were using say four independent outputs, mixing them, which would need 4 VCAs, 4 mixers, and then 2 cross mix between them, you'd need some sort of complex modulation source that's able to give you a sort of balanced mix between the voices. This is now consolidated down to just a couple of LFOs, adding a bit of dynamic motion to 2 parameters. Okay, well, I hope this sheds a bit of light on some of the internal routing capabilities of the CSL, and you know, maybe inspires some different approaches for creating your base waveforms for subtractive patching or whatever patching you fancy. Thanks for watching.